Hello everyone. In this video, I'm going to discuss about the free body diagram of an object resting on an inclined plane. So let us consider an object which is resting on an inclined plane, which is at an angle theta like this, right? So let us consider an object with weight W, a mass M, which will give the weight equal to mg. So let us see what are the different forces that are acting on this block so that we can draw the free body diagram of this with all the forces. So what are the different forces that will be acting on this one? There will be a normal reaction acting perpendicular to the surface of contact like this, right? Normal reaction. And I am considering a surface which is having enough roughness to give the frictional force on it. So there is a frictional force acting on this one. In which direction it acts? It acts in the opposite direction to the possibility of sliding of the block. So because it is inclined in this direction, right? So there is a possibility for the block to slide over in this direction due to gravity. So in order to oppose this motion, there will be a frictional force acting in the opposite direction like this. So this is the frictional force. Frictional force, right? So frictional force is acting in this direction, normal force is acting in this direction, and normal reaction is acting in this direction, and weight is acting in this vertically downward direction. So now let us see what are the different forces. Let us draw the free body diagram and see what are the different forces that are acting on it. Right? This is mg. Then normal reaction Fn and a frictional force Ff. So for us to easily analyze the forces, always it is better to have all the forces, all the components of forces in two perpendicular directions. So here already we have two forces Fn and Ff which are perpendicular and parallel to the inclined plane. So let us also resolve this weight mg into two components, one perpendicular to the plane and other one is parallel to the plane. So how to resolve it into two components? So if you see here, this plane is inclined at an angle theta to the horizontal and this is a vertical force. So therefore, it is making an angle theta to the direction perpendicular to the plane, right? So this is theta. So you can resolve this into two components. One is in this direction, other one in this direction, right? Like this, you can get. So what are these components? Because this angle is theta, right? This angle is theta here. This is theta. So you can consider these two components as mg cos theta and mg sin theta, right? When you consider the resolving of the resolution of these forces into two components, this mg into two components, you get them like this. So now let us again draw the free body diagram in a clear way, right? So you have a normal force Fn, you have frictional force Ff, and we have the component of weight perpendicular to the block, perpendicular to the plane, I'm sorry, mg cos theta, and parallel to the plane mg sin theta, right? These are the different forces that are acting. So what is this frictional force? It is always equal to, less than or equal to, you can say actually, to the normal reaction into ms. What is this ms? Mu s. Mu s, what is this mu s? It is coefficient of static friction, which depends on the two surfaces which are in contact, right? So why actually we are writing like this, less than or equal to, the maximum value is equal to this normal reaction multiplied by the coefficient of friction here, right? It is always less than this one. It depends on the other values, other values of the, I mean like inclination and other things. So let us see, and what is this Fn? Fn is when you consider the equilibrium of these forces, that is the forces which are perpendicular, acting perpendicular to the inclined plane. Fn is equal to mg cos theta. It will be equating this one. This is mg sin theta and this is less than or equal to Fn into mu s. So we are considering the case where the object is in the static condition, right? It is not moving. So in what condition actually it might move? If you consider that mu s is constant, right, there is certain inclination of this inclined plane at which it can start moving. When it is at the verge of movement, means it's about to move, just before moving actually, this will become equal and they will be in the equilibrium. These forces which are acting parallel to the inclined plane are in equilibrium, right? That is mg sin theta, right, is equal to Fn into mu s, or you can say that Fn is mg cos theta. So mg cos theta into mu s. So from here you can write that m gets cancelled and you can write mu s is equal to gg also get cancelled, and what do you get? Mu s is equal to sin theta by cos theta, which is equal to tan theta, right? You can say this. So now, at what angle actually it will move? What is the maximum angle that it can move is equal to tan inverse. This theta is tan inverse of mu s. After that, if this theta is more than this particular value, the block or object tries to move in the downward direction, right? So this is about the object which is resting on an inclined plane when it is in static condition, right? When it starts moving, the things are again different. So we have to consider the acceleration and how to find the acceleration, all those things. Those things we'll see in the coming videos. Thank you.